All right, this is the respiration accounting activity part 2. So what I've done is I'm just highlighting the products from glycolysis, pyruvate oxidation, and Krebs cycle that are going to be important for this last stage, electron transport chain chemiosmosis oxidative phosphorylation. So I'm only highlighting the 2 NADH that were made during glycolysis, the 2 NADH that were made during pyruvate oxidation, and then 6 NADH and 2 FADH2s from the Krebs cycle. You got all the other stuff filled in when you did activity 1. But this is activity 2, which is just, we're looking at this last stage of respiration. So by the time you get to this last stage of respiration, glucose is completely oxidized to carbon dioxide. And what's left are these electron carriers that I've highlighted. And so the reactants for this phase involves what's now a total of 10 NADH molecules from the original glucose that started glycolysis, and then the 2 FADH2s. All right. What you also have at this stage would be the oxygen. You may have noticed that, oxygen. The oxygen 6O2s finally come into play. And also we're going to have, 30-ish ADPs and 30-ish. And you'll know why I say that when you watch the lecture. Inorganic phosphates. Something like that. So those are kind of your reactants if we're trying to break it down just for this phase. The location, the electron transport chain is located in the inner membrane. And then there's going to be a really important proton gradient that is across the matrix and the intermembrane space. So kind of all of this is involved. Inner membrane with the matrix on one side and the intermembrane space on the other side. Now the products, you have to learn the process when you look at the lecture and the animation, but the products here are going to be the NADH and the FADH2 are going to be giving up their electrons, so they become NAD plus again, 10 of those, and 2 FADs. And those guys can go back to glycolysis and pyruvate oxidation and Krebs cycle to pick up more electrons. The oxygen, remember the oxygen is the final electron acceptor at the end of the electron transport chain, so it becomes converted into 6 waters. And the energy from the electrons moving down the electron transport chain and the building of the gradient of protons and the release of the gradient of protons through ATP synthase will provide the energy to put the ADP with the PI to make 30-ish, I say ish, ATPs. And that is really what you're trying to get from cellular respiration. So all the energy, some of the energy anyway, from the original glucose is now bound into the molecules of ATP.